So thank you all for coming here. Believe it or not, this is like, I think this is the 15th event that I've organized. I've been organizing this since 2017. I was working at Bank of New York. They had their sort of technology innovation office in Palo Alto. And a long story short, I was really jazzed about project management and program management. So I started this meetup called Silicon Valley Project AI. And we had our first meetup in 2018. So now it's like, 7 years later, I guess. And here we are, Silicon Valley AI think tank, something very passionate to my heart of sort of AI working, or people working with AI to empower humanity. So we got a great night with some great speakers. But before we jump right in, oops, I should probably use this guy. Uh-oh. I'm sorry. Oh, my name is Robert Franklin. Yes, I am Robert Franklin. I am the founder of Silicon Valley AI think tank. I'm the founder of sort of this meetup from 2017 that's been going on. I also write, here's a good question to start out with. How many people read AI Quick Bites? Is there anyone here from AI? Oh, yes, I am so excited. Thank you I want to definitely talk to you. So I've been writing a newsletter for about a year and a half now, all on, strategic AI and leadership in the enterprise. I sort of curate articles on AI, and then I kind of put my personal experience on top of that. So I send that out once a week on Sundays. And I'm a little thrown off because I'm still waiting for those two people to come in, but we're just going to get started here. So we got a great night for you. We got John Kanellakis, founder of 10D Corp, and he's going to tell you, how to build a model on the sheet, which is really exciting. We have Darius Amrani, CEO of Scorecard and Evaluations. And if you know about evaluations, we were preparing for this meeting, and what I thought was really cool is there used to be the saying in Silicon Valley, like, fail fast, right? And what I found is that when you say fail fast to most people, that is not a positive thing, right? What you want to do is learn fast. And evaluations are all about learning fast. And you're going to learn from, a world-class evaluator. So let's see what else we have here. It's not working. Tech support. It looks like it's moving, but it's not. All right, let's see. I'm gonna have to click it. So, I'm gonna go pretty quickly here, but this is the AI ecosystem. There's Silicon Valley AI think tank. Just launched the website today, so we're really excited about that. There's the AI Quick Bites newsletter. And then I just I cut up this video from today and I put it on YouTube, and there'll be 2-minute kind of little snippets of sort of different people talking and me, like when you want to laugh a little bit, and I'll probably put maybe a little beverage video of just about my favorite beverages. Okay. Let's see here. All right. So this can't be, possible without having a host. So I'm fortunate enough where I work at Intuit. Intuit is a world-class technology leader with QuickBooks. That's the building I work in, and I feel lucky every day I get to go there. But they provided this space and all this food. So let's give Intuit a nice round of applause. Thank you, Intuit. We really appreciate it. And then our sponsors. So Sakura is a very good friend of mine. Oh, sorry. A very good friend of mine. Jackie Cineros, and she is a designer. So if you're looking for, website design, if you're looking for personal sort of design assistance and personas and wireframes and all that kind of fun stuff, definitely check out Sakura. She used to work here. I met her at Intuit like 10 years ago. Scaled Growth is Anna Wong, and she spoke at our Women in AI. How many people are here from our last meetup? Okay, we got a couple. Okay. So Anna spoke. She is the CEO. They are building a couple of different things, sort of AI agents to help support you in different roles and personas in the organization, and a lot of finance, sort of AI as well. Check out Scaled Growth. Anna Wong is really a powerhouse in the Valley. So check out her company. And she's very supportive. Matter of fact, Darius, who's speaking here today, she sort of introduced me. He wouldn't be here if it wasn't for her. So I really have a big shout out for her. Oh, cool. So quickly, if you want to say like, oh, how do I get in touch with Rob? Here's my LinkedIn. Here's my Silicon Valley AI think tank, which may not work. I tested it last night and it wasn't working, and I haven't had a chance to get back to it all day. AI Quick Bites is the newsletter, and then AI Quick Bites YouTube is the YouTube. I'll also show this at the end of the night as well. 1 second. All right. Oh, this is my favorite. I love this part. So, okay, first of all, every time like someone says, oh no, we're going to have to do an exercise, when I attend these events, I'm like, oh, fuck. Oh, sorry. I'm always like, I'm darn, I don't want to talk to anyone. But what I promise you is we are going to take like 10 minutes. And part of like what I think is one of the most important parts about sort of this event is that you get to make connections. You get to meet other people. I think we're spending way too much time, ironically, on computers and, on our phones. It's great to see people, get out, learn. So for 10 minutes, kind of try to just break up into groups. Like, why did you come tonight? And like, what is the one question you were hoping to get an answer like from this event? So it's, let's see, it's 6:33. We'll go to like 6:45. And what I promise you is I'm gonna have to scream and yell, like kind of get you and pull you away from talking with one another. So take those 12 minutes. If I can't tell you how excited I am to have the next speaker who's been patiently waiting to come up here to share with you about his company, Scorecard Evaluations. Darius Amrani is, a leader in his field. We are very lucky to have you here. And I feel honored to have you speak at the Silicon Valley AI think tank and share how important evaluations are, right, to the quality of AI and the products that we release to the public. So I don't think there's anyone better to share about that than Darius. So I'm gonna hand it over and give a warm welcome. It should work, okay.
Can you guys all hear me okay? So Rob is too kind. Well, first, I'd love to get a picture of this event because I think it's awesome how much enthusiasm and excitement there is for AI evals, which I think is really important, but sometimes a little less sexy. So let me grab this. Oh my. So we'll kick it off. So what I'm going to talk through is how evals are effectively, yeah, go ahead.
Recorded.
Rob. Perfect. Okay, first off, how many people have heard of evals, like as a concept for AI? Yes, no. Okay, about quarter, half. Okay, great. So I'm going to frame evals as what I think they are, which is simulations. So I view evals as the way to build better AI products. So first, let's take a step back into like what we as builders and members of different companies do. So we want to build the best product, right? And the way we do that is by listening to users, where we're building ultimately for end users. And that feedback is basically the fuel that, especially for startups, is what we take and use to make better products. And so you've probably all seen this kind of a classic product iteration loop. You, let's say you've shipped a version of your product, you get feedback in all different forms, maybe sales, support tickets, customer conversations, et cetera. You gather insights, either reading them all manually, maybe you have an automated process, you have maybe another team, et cetera, and you make product decisions based on that. You say, okay, well, our customers aren't happy with our support experience. We should change the UI or we should change the AI. So that's really where evals are really powerful. Evals are effectively simulations of future feedback. And it's a pretty like simple statement, but there's actually multiple layers to it. So if you think about the traditional product development cycle, and this is still true in the AI world, you build your product, you deploy it, you basically go out to all your different users, and they start getting feedback. So you'll get a trickle of emails, maybe support tickets, maybe thumbs up, thumbs down. There's lots of ways to get that feedback. You then look at those cases, and then you identify patterns of issues. You say, this is a cluster. You traditionally might have product manager or the CEO or whatever do that. And then based on that, you ship a new version of your product. Now, in the AI world, what ends up happening is you hope that that change you make fixes the issues you've seen and also doesn't break other users, because these systems are non-deterministic. What that means is if you use ChatGPT, you ask the same question twice and you get different answers. And so this process actually sucks. Like it takes on the order of, let's say, 10 days to wait for that feedback, or maybe even weeks or months, and you don't even know if you fixed it or broken it for someone else. And so what evals are is that inner loop. So we like to call it a scorecard, the sandbox before you deploy. So you think about, let me take all those issues I've seen, all the things customers have asked me. Let's say we've had a customer support chat and customers have said, hey, I want a refund. That is an input. And I basically change my system. Let's say I change my model, I change my prompt, et cetera. And then I run my evals and simulate, okay, would this user have been happy? And so that's, in a way, it's a proxy for the end user experience. You can never replace, of course, that final production monitoring, but this is where simulations are really helpful and evals are really fast. It takes your process from 10 days to 30 seconds. So, I'm not the only one who said this. This has kind of become a thing. So Mike Krieger, CPO of Anthropic, if there's one thing we can teach people, it's that writing evals is probably the most important thing. Gary Tan, evals, so he's CEO of YC. Evals are emerging as the real moat for AI startups. Right? Everyone's like, there's no moat. Evals are the moat. And Greg Brockman from OpenAI, evals are surprisingly often all you need. And so what is an eval? Everyone's like, okay, great. I want an eval. How do I get it? What is it? So there's kind of three core parts to an eval. So one is the model, like the system under test. And we'll dig into that a bit. Another component is the test set. Okay, what am I asking? So what are the tasks my customers are coming to me with? What are the inputs to my system? It could even be a workflow with no customer, but I have like a set of documents. That's kind of the test set. And then the metric, like how do we actually measure and improve performance? Like how do we get better? What is performance? What is good? And you guys may have seen these things called benchmarks, which everyone likes to report. Look, Gemini is the best on these benchmarks. OpenAI is the best on our benchmark. A benchmark is just a set of evals. It's we cluster together the test set of the metrics and we say, hey, look, 1,000 of these, that's the benchmark. And I have a separate talk I gave at the AI Engineering Conference around why a lot of these benchmarks actually aren't that useful and what we're doing about it. Okay, so with this in mind, I'm going to take a side road and describe how Waymo does eval. I realized I didn't do a great job of giving my background. Prior to Scorecard, I was responsible for evaluation at Waymo. How do we know the car is safe? How many people have ridden a Waymo or tried a Waymo? Okay, more people than the evals. So if it's good, you're welcome. If it's not, I don't work there. So we'll do a side tangent about like how Waymo does AI evals. And ironically enough, it's very similar. So you think about the three parts of the model, the test set, and the metric. So the first part is, okay, the model. So we have a really complex, actually LLM on the car, and that's the first component. It's like, okay, let's change out different parts of the model, and let's see how it would perform in different situations. The second part is what cases have we seen? And so what you actually see on the left here is a side-by-side real world and a version in simulation. That's how we do evals at Waymo. You basically take the cases you've seen in the past. Again, you think about your user inputs, except for it's just the world, and we recreate those in simulation. And those are kind of our test cases. Finally, what is good? So there's tons of different metrics you might look at, but one of them that I'll highlight here is collisions. As a general rule, colliding into other things is not a good driving behavior. And so you can imagine collisions as one of the metrics we might run on these evals. And so what we effectively do at Waymo is we take all these situations we see on the road, we take these metrics we developed, and then we create a eval suite, which is each one of those cases now built up into a large database. And this is really where that Gary Tan quote comes into effect. This is your feedback mode. This is what makes Waymo valuable. It's not the onboard model. It's actually the aggregation of the experience, which if you were to basically lose that model, you could retrain based on all the eval test cases. So I think this is why evals are so important, is because that is all your collected user feedback, which simulates how it would perform in new situations. So let's transition and talk about what that looks like for AI applications. Very similar. So the first part we think about of the model. Now, when we say model, we actually tend to mean like AI system, because a lot of, I'd say the vast majority of companies outside of our Anthropic and OpenAI are building products using these models. And so when we think about the model of your product, it tends to be built up of the model provider. I might use OpenAI, Gemini, might actually switch between multiple of these. The prompts, so you can have different things that you have as a template, which is like what gets fed in. And then you may have other components. You could have embeddings, you could have document parsers, you can have like basically ad hoc, as many steps you want in your pipeline. But ultimately it comes down to the system under test. So that's kind of the model. The next part is your test sets. And this is actually, in a lot of ways, we're really lucky that our data is text, because we can go to all our real conversations and save them. We can say, hey, we've had users ask about refunds, we've had users ask about escalations, and save those. And that is the test cases that we're building up into our eval suite. And finally, the metrics. So this is kind of the area where there's a lot of new work happening. So you can think about metrics as composed of potentially human ratings, which is like, hey, let me just look at the results, or pay other people to look at the results. Another option is using code, so like heuristics, where you basically write, okay, does it match, does it not match? So a classic example, before I was talking with someone in the back about unit tests, that would be like an example of a traditional eval. And then maybe one of the most useful and most novel is LMS judges, which means like, hey, why don't I use another LLM in order to judge the output of my model? I can get into all the reasons why that's powerful, but also you need to align that with, again, your user feedback preferences. So that's the third and final part of an eval. And so yeah, when you want to operationalize this, you kind of break it into the steps of like, okay, well, first I want to gather data. So it's kind of the test cases I want to collect, choose the metrics. What is important for my customers? If I think about evals as simulations of future user feedback, then what do my customers care about? Like, what was a good experience, and how do I extract that into this is good for those reasons? Then you can choose some models. So your LLMs, you can try different ones. And then finally, you run your eval. You basically get your scores, and then you can iterate. So this is like the fundamental core loop of product evaluation. So if we can help, of course, we automate evals at Scorecard, basically enabling this workflow. But if there's one thing I want to leave you guys with, it's that the best AI teams are simulating future feedback. They're not deploying and waiting weeks and months for every iteration. They're simulating what users would need through evaluation. So I'll stop there. Questions? Yes.
Raise your hand.
What's your name? And
I'm Gaurish. I work for Broadcom, the private AI foundation team. We basically use evaluation frameworks like LLM as a judge and traditional ML related scoring metrics like F1 and all those things, right? So quick question to you, how many metrics do you support, and are there any metrics that can reduce hallucinations?
Great question. So question was, how many metrics do we support? And then are there any metrics we support or otherwise that can reduce hallucinations? So on our platform, we have like templates. There's also a ton of open source metrics, so you can use those in combination with our platform or another. In terms of hallucination, it's actually very interesting. There's when you think about hallucinations, a lot of you actually need to dig one level deeper into what hallucination is. And so there may be, we kind of use this umbrella of like models hallucinating in terms of saying things that are factually incorrect. But that is actually one type of hallucination. And so when you think about factual correctness, which is probably one of the most common ones, typically what you want to do is you want to ground it. And so that means that you may have, let's say, a data generation, but I also had a database where I had facts that came from. So you can run a metric which says the facts that were the original context versus generation, was that grounded? So was that basically relevant based on the facts that came out? So yeah, I'd say that's probably one of the most common ones. And then there's other ones depending on like what issues you're actually seeing. Yeah.
Piyush Malik, I run the digital agenda. And my question is are there any standards or for evals across different companies or an industry body managing that?
So the question is, are there any standards for evals? Yes and no. So there are certain standards, that's what we call benchmarks. And they tend to be, let's say, common international math Olympiad questions, or they tend to be like reasoning questions. There aren't that many domain-specific benchmarks, which is, I think, what a lot of people care about, because like I'm not building a math test taker, I'm building a legal app or a healthcare or a financial app. And so those are much less common. There are some emerging. We're also actually working with some financial model providers on developing that. I will say the best evals tend to be more particular to your domain. So the best evals are ones that your customers may be experiencing. A bit. I will say there are some, like, let's say toxicity and like bias. Those are maybe kind of common across the board. But when you think about product performance, that tends to be a bit more Wild West. Yeah. Cool. Other questions? I'll also take one from here. Third. Awesome. Yep. 100%. So a few things. So the question is, let's say I've trained a model. What is the benefit of using Scorecard or another platform like it instead of maybe doing model level evaluation? So I think that's a great question. For a lot of companies and a lot of teams, they're building on top of models. So I'd say if you're only training a model, where us or a platform like us is not the right solution. So that's probably where you want to use like weights and biases. So OpenAI, Anthropic, people are training models. They want to look at precision recall curves. They're going to look at like you said, test eval splits and kind of assess performance. Our customers and what we're really excited about is people building products using LLMs, building agents, building RAG apps, building workflows. And so there, the model provider is actually one part, and honestly, like a commoditized part. You like swap between them, you have no loyalty. And so it's systemically built around that and looking at product performance versus just model performance. Does that answer your question? Bingo. Yeah. Yep.
AI agent, the end-to-end solution should work. Then I should have my own test set for my workflow or business logics.
Yeah, and I think this actually goes back to the earlier point from what was the Piyush around benchmarks. So when let's say Gemini is really good at math tests, great. For your application, let's say only that LLM step, you're actually looking at, does it generate good customer support response, which is a very different metric. So even in the context of evaluating not the whole system, but one step of it, like you actually want to look at different evals than you would if you're looking at the general benchmark performance. Does that answer your question?
Do you extract some more metrics that usually the business owner doesn't have insights to?
Yeah, that's right. Cool.
Thanks.
Okay, and I'll take one from the right because I've been neglecting you guys. Okay.
Great.
Thank you.
See evals as similar or different from observability? And then what is your thought on what will happen in the future with those two practices? Do you think they'll converge or not?
Yeah, it's a great question. So the question is, observability and evals, do they kind of converge? How do we view them separately or together? So I think this goes to oh, sorry, I'm going the wrong direction. So this process we kind of described. So when you talk about observability, it has different definitions depending on whether you talk about model observability or like systems observability. So model observability will be kind of that like distribution changes and like drifts of performance. When people talk about LLM app or agents observability, they're usually talking about how does it perform online, right? How does it perform in the traces of the system? Like look at all the different parts of it. So we see observability as like a key input to evals. So that is all the gathering data. It's like, let me log and then capture that so that I can run evals. So to us, we support like OpenTelemetry, which is one of the largest open source observability solutions. We view it honestly as a commodity. We think the big value is like taking those, transforming them into like structured. But if I can give you one more version, I think the long-term view is actually you take those evals and you're able to auto-improve your system. So you constantly get those new observability logs, and then based on those, you can tweak your system using AI and make your product better. Okay, I don't know, Rob, I feel like I'm running out of time. Maybe I'll do one last question, or how are we doing? Okay, cool.
So my question, how is the evals different from say traditional products? We had traditional data products and we cared about KPIs even then. And we have model level evals that are like, that's actually model KPI. But so where does AI eval differ?
Yep. Okay, so the question was, we've had different forms of like evals in the past. We've had, let's say, product level KPIs. How do AI evals differ? Great question. So I'd say on the engineering side, we've had unit tests. And unit tests would basically tell you if your app is broken. What they wouldn't tell you is your app getting better, right? A unit test can only tell you if you're regressing. What's happening now is like you actually use your evals to make your product better. Like you set a benchmark and you say, let me hill climb and improve performance. So that's maybe one of the big shifts. I think we talked a bit about like the model level performance differences. I think the other thing you touched on is KPIs. So that would be like, again, tying back to observability. End user customer experience. Like when I look at KPI, maybe it's like, so I worked at Google as well. It might be like dwell time. So how long am I spending on a page? How many purchases am I making? What is my, again, like thumbs up, thumbs down, like satisfaction? So these are actually like lagging indicators. Like if I made a purchase, a bunch of things upstream had to have gone right. And so evals are actually one step removed from that. So they're a way we would call them proxy metrics. That means like before you crash into their car, you were tailgating. Before you crash into them, you maybe like swerved too much. And so they're earlier indications of performance that ideally correlate with those product level KPIs. So great. Question back? Hey, can you speak up?
LLM as a judge,
Yeah.
right? Can you speak about some use cases where you feel LLM as a judge works for your customers and some cases where it actually struggles?
Great question. So the question was LLM as a judge. We talked about how it's really useful. where does it work well and where does it struggle. And there's a whole body of work around this. I'm also happy to refer you to Eugene and Shreya, a few other thinkers around this. In general, LLMs as judge tend to do well in the same ways that humans do well. So if you give them a very specific task with clear guidelines, they tend to answer effectively in there. The other reasons LLMs as judges tend to be really effective is they tend to be consistent. So if so when I worked on search or when I worked on Waymo, you can have two different human raters, and those raters may not agree. Right? Like if I look at a search result, or if I look at a trajectory of the car, I could say this is good, and Abhishek in the front might say this is actually bad. And so the real power of LLMs as judges is that they encode what good performance looks like. So this goes back to, again, evals as your moat. You're building up a data set of what we as product owners, we as a building team believe is good, and then kind of able to consistently reproduce that. Other rules like being very specific, using pass-fail. I'm happy to also share out some different references on how to build good LLMs judges, but that's the high level. Cool. Okay. Any last questions? If not, okay, there you go.
Could you speak a little bit more about the comparison of the time between building AI agents and making them more accurate? And what do you think, or what is your point of view about training these models with synthetic data?
Got it. Okay, so maybe on the time piece, is it the relative amount, or just to say that the first one, the time spent building versus?
Yes, versus building versus making the model accurate.
Yep. Okay, so the question is, how do you think about the time you spend building product versus evaluating and iterating on it? And then the second part is utility of synthetic data for these applications?
Using synthetic data to train the model.
Great question. Building versus evaluating and deploying. I think what's kind of fascinating is it used to be building was like 90% of the product challenge, and that's kind of where unit tests came in, right? If my unit test failed, my app was broken, go fix that. My app works, I'm done. What's happened is the time to build an app has almost gone to zero, right? Like you can build an AI app in a weekend and deploy it. The problem is it doesn't work. I also I made a bet that you can actually build a very poorly performing self-driving car in the course of a week or two using LLMs. The challenge is, again, like evaluating, it doesn't work. And so I think this shift has happened. Now, I would say for early stage builders, it's still really valuable to iterate on different versions of your product, make sure it's actually valuable even in your demo. And we call those like vibe level evals. It's like, look at it, be your human judge. But once you're actually trying to deploy to market, it's really crucial to start building some evals, because otherwise your first customer, they onboard, they say it doesn't work, you don't have a way to fix it. And so that's a really scary place to be. And then second question on synthetic data. So, as we saw at Waymo, we did a lot of synthetic data generation, right? The key part here is what we call the sim to real gap, which is how representative is my synthetic data of real data, right? Like, does it represent the corpus of, user queries that I've seen before, or is it kind of synthetic? Is it like fake? Is there divergence there? And there's ways you can also, again, use like LLMs to validate that. But synthetic data, I think, is really powerful, especially if you're finding poor performing cases. You see using observability where you did poorly, and then you create lots of examples around that. Cool. Okay. Thank you so much, everyone. And if you have any questions, feel free to reach out. My email is dare@scorecard.io or team@scorecard.io.
Thank you so much. Very well done. To make this simple, right, is not easy. So great job. Oh, thank you. Is not easy. Eval. So, where I say that, it's about learning fast. My prediction is the companies that are going to win are the ones that learn the fastest, right? So if you can learn and go through these loops really fast. Now, Darius is speaking about going through these loops before you go to production. But it's not only that. Once you're in production, right, you're worried about drift, right? You're worried like is your model changing? If you don't have the ability to learn fast all the time, iteratively and on the fly, you know, that's when you end up on the front of the New York Times, right? Because your model, something happened. So this is an extreme, and you know what you just said that really kind of, you can build an app in 2 days now. I'm building apps in 2 days and I don't even know how to code, which is dangerous, right? You know, so it's not about the app anymore. It's really about the learning, the safety, the validation of that app. So that's a great takeaway. Thank you so much.
Thank you.
All right, we got our next little fun thing. And you know what? I'm just going to be really goofy. I'm going to take a picture of everyone, right? And if you all just wave, let's see, everyone wave. Yeah. Oh, that's my thumb. Okay. So this is a really cool thing. I am a very fortunate person, right? Because I'm going to embarrass my wife. She's going to get very embarrassed back there. She's helping me out. She drove all the way out to help support me. So what we're going to do now is we're going to seed this room with fun types of questions, right? You'll break up into groups of 2, 3 to 5 people, and you'll discuss. So really excited. And I want to try to get this back on track so people have made commitments as well. John Kanellakis. I don't know how we even met. Like, you know, I always say that a lot of how this comes together is divine intervention, right? Like magically something will happen and I'll say, all right, let's do another meetup. And then I'll just sort of, I don't even know what the theme is. And it just magically happens. And then magically, John and I connect on LinkedIn. It's like magic. I think it's the best thing about LinkedIn, where you meet a lot of great people and interesting. And then I said, hey, would you like to talk at a meetup? And because I really liked the work that he was doing, kind of building a model on what would you say? Cheap is not, is it cheap or cost? My mom would say cost effective. Cheap, look at an air and cheap, right? So, you know, John had the opportunity to work at Netflix, at Roku as a senior engineering leader. So you're going to hear from the source sort of his experiences and sort of starting his own company as well, sharing the war story, sharing what he's learned to help you on your journey if you're interested in building a model. So we're really excited to have John here. Thank you so much for coming, taking the time, talking with me. Give a hand for John Kanellakis.
Thank you. Oh, I've got. Yes. Thank you. It wasn't actually magic meeting. It was AI and probably an algorithm on the LinkedIn recommendation system. Hi, I'm John Kanellakis. Pleased to meet everybody here. Thank you for coming out and taking some time to, participate in my passion. I'm John Kanellakis, an AI researcher, founder, head of AI, machine learning, and factory. My goal here is to turn everybody into a model developer, because developing AI models is fun and it's important, and it's really the way I see the future of software engineering. The way I see it, software engineering is going to be transitioning more from telling computers what to do through programming and code and instruction sets to teaching them how to do things. And we're going to get more granular and more domain specific, and we're going to go vertical into more areas than ever. That's because AI, machine learning, generative AI in particular, is really good at ambiguous information. So classical programming teaches us that you have logical conditions. If A, do this, if B, do that, if C, do something else. But it doesn't know what happens when X comes up. And it just kind of like, exception. But what we can do is have a platform that learns. Okay, well, I don't know. Let's try this, see what happens. That may have worked or it may have failed. And after enough examples, it can actually adapt to the situation. And we get deeply personalized experiences in software and really creative and unique problem-solving opportunities. A lot of folks largely interact with large models. These are like the ChatGPTs, the Anthropic Claude, Gemini, the big guys, right? But what we're going to be seeing is more and more smaller models and micro models. And I'm pretty sure everyone in this room at some point is going to be writing their own models. If you write code today, you'll probably be developing your own models not too far from now. Micro models are great for solving very specific problems, and specifically specialized models that can do very specialized tasks that work together in an agentic workflow. So that's where things start to really shine and get super exciting. And by the way, I get crap for this, but I tell some friends, if your startup is basically a value add on top of OpenAI, on top of ChatGPT, where you're just making API calls into one of the GPT models, that's really, you're not an AI company, you're an AI consumer. And the real IP, a company, I think Rob will figure out what that company is, and tomorrow he'll start coding, and in 2 days he'll have a competitor for you. So your real IP is in the models you train and the models you develop. You own it. You can do whatever you want with it. You can monetize it. You can license access to it, anything you want. I have my LinkedIn at the end, by the way. I advise a lot of startups. And I really do answer every single question that comes in. So if anyone has questions, feel free to reach out to me and I'm happy to help. And that said, I'm going to be talking about AI model development. And everyone in here who's a startup founder or thinking about it, or is a software engineer and you're working on problems, I kind of structure this in a way that I'm hopeful that everyone can kind of in their head think like that's me and apply their terms, swap them out for what you're working on. So like I said, most of us are familiar with very large models, the ChatGPTs and the Claudes and Anthropics. They're great, right? They can answer pretty much anything you can imagine. And you give it a little tiny prompt, write a poem for me, write a love poem for me. And what you'll get is a nice love poem. Sure, that looks great. But what if you wanted something a little bit more specific? I want a love poem that's kind of more like my style. And so what you do is you give it a lot of examples. Like I wrote like 50 love poems. I'm not that talented, but let's say I wrote 50 love poems. And these are examples. So my prompt is still, write a love poem for me. And then I give it these examples, or here's 50 of them they're my style of how I write. Here's how I do things and how I put it together. There are two problems with this approach. One, it works great. But problem number one is we're finding that the LLMs start to bias whatever's at the end of that list. So if your poems start getting a little dark for whatever reason, then the output's likely going to skew that way, because that's going to have the highest probability of output is what matches the later examples. The other problem, though, is even worse. There is a finite length of information you can stick into that context, into that prompt itself. And you may want 50 love poems, but what if you want 5,000 love poems? Well, you're going to run out of space. It won't know what to do. The whole thing just kind of falls on its heels. But you do get, for a finite number, like 50 love poems, it looks pretty good. The real answer is, what if you take those examples, those 50 or 5,000 poems, and instead you bake it into the model itself? So the model just knows it. It's part of its fundamental knowledge. It doesn't have to pick up a book and look at your examples. It just natively knows that as part of its inherent memory. So that's the part we call training a model or fine-tuning that model. We're going to take that data, all those 50 love poems, ideally way more than that, by the way. We're going to actually go through a process that bakes that into a different AI model. And now, when we've got that new AI model, we can go back to our initial prompt, like, hey, can you create a love poem for me? And it'll create it in the style that we wanted, the style that we've trained it to be native with. You get great responses too. The other best part of that, though, is we've fine-tuned and trained this model to be something very specific. This is my love poem model. I don't know why I'm stuck on love poems. This is my model that specializes in generating this content. And so it doesn't need to be a massive 500 million parameter AI model. which is expensive on the hosting side, expensive at inference time when you actually want to prompt it and you've got these token constraints and token costs and token fees. And instead it can be a very small specialized model, and it's cheaper. It's way faster. And I've got great resources for startups to consider when they're ready to do this. So we have a lot of value, but as you can probably imagine, it all starts with the data. Data. Now there's two ways you get your data. You either find it, buy it, or you create it. And if you want to find it and buy it, there's great resources out there. Data.gov, for example, is one I've been hitting up a lot lately. It's a free data. It's basically your United States government data on the internet. It is the census, it's Bureau of Labor and Statistics, it's wage information, it's COVID cases, it's anything you think the government knows about the population, not any individual. The population of the United States, it's there. Some of it's CSV, some of them are API endpoints, some of them are even like Excel spreadsheets. That's sad. So there are a lot of different sources. Another are tools like InFactory makes a tool where you can just bring in lots of different disparate data sources, and it can actually culminate it all together and then create a training data set for you. Oh, Kaggle is another great resource for data sources. Do that one a lot. So a lot of great resources for finding the data. Now, what's more interesting is creating your own data. And I think someone mentioned synthetic data. You mentioned synthetic. I'm gonna call you out. And that's what we're gonna talk about today. So creating synthetic data is a fantastic way of building your large repository of data that you're gonna use to tune and train your own personal, I almost said dragon, AI model. Not dragon, right. Train your own model. And so the way we do that is, I gotta read my own slides because sometimes I forget which presentation I'm doing. Right, the way we do that is you kind of cheat. You ask a smarter model, right? So you ask a system like a very advanced ChatGPT 4.5 or an O3 model, and you ask it for give me a bunch of prompts and give me a bunch of answers, and you can get that training data set there. That's that transfer knowledge. You can ask a lot of questions about a lot of things. It'll generate information for you, and you build up a collection of information that you want to train on. So that's one. It's only going to be as good as that superior model, but it's a very effective way to generate a really good training data set. And essentially, in any sort of model, what you're looking for is a prompt or what goes into the model, and then the response, what comes out of that model. And it could be text, it could be images, it could be audio. We're going to talk about 3D shapes. The other thing, though, before I talk about that, one, you need data. Two, you need processing power. And training AI models takes an enormous amount of processing powers, and GPU resources are very, very expensive. So I'm going to talk about how you get that on the cheap, or how did your mother say it? Cost effectively. How we get it cost effectively or on the cheap, and still produce fantastic models out of it. Because training models can be very expensive. It could be as little as a few $100s. There's resources for that I can share, as well as tens of thousands of dollars. Less inclined to share that one. And it all comes down to the GPU and then the data you have. Okay, so how do we get these lovely GPUs for cheap or free? The big cloud providers. So Google Cloud Platform and AWS, Microsoft Azure, they all have programs for startups. And maybe you don't have a formal startup, but create one in your garage or basement and call it yourlastname.com or .xyz and say it's a startup, and then use that QR code and sign up as a new startup. The more you convince them that there's something there, the more they're likely to just give you their entry-level package, which vary, but they are generally around $2,000. And you can get a lot out of $2,000 because these GPUs, they're generally about $4 an hour. So that'll last you a full month, right? Doing the math. If you want more, because $2,000 wasn't going to cut it. I talked to them about the project we're going to see next, and I'll show you how I did it when I did. And I demonstrated like something super creative as a new idea, that this had some actual value, like someone would actually use this model to do something, maybe not, but like I told them that. And then I had a plan for how I was going to use that money that they were going to give me. And then I went with Google Cloud Startups. And based on that, I created a plan, and they did award me an increase to $20,000. I'm pretty sure that's not under NDA. So I'll double check, but it's too late. We're recording. Everyone's heard it. So fine. 20,000. You heard it here. I'm going to jail. Once you get those resources, once you get the money, once you've got the credits, I'm sorry, they don't write a check. No, they're credits on your account. And by the way, you have to attach your own payment system to it first, which I will have some important notes about that. Oh, it's actually in this slide. Those resources are metered by the hour. So there's two things you want to do. One, you want to really, really plan your model training very meticulously. The other thing you want to do is set billing alerts. I set a couple billing alerts. One is a daily billing alert. I never want to spend more than $250 a day. If I do, like text me, call me, whatever, something's wrong. Something, it's like you've left the water on. And believe me, if you've ever left the water on at home, the water company, I think you get one, gimme, but then they really fine you. It's really expensive. And then the other is after you've used all your allocation, financial allocation, in whether it's 2,000 or the other number, then it hits your credit card, and then that can get really painful. Then it's on you. And you want an alert well before it reaches that level, so you know, like just put the brakes on, shut everything down. Don't use my credit card. Forget it. The other thing here about batch processing and sharding is that these GPU servers run on they're metered on an hourly basis. And folks who've done a lot with computers, or even had long running jobs or big downloads, know that, you kick off a process and you're not going to sit there for 1 or 2 hours and just stare at the screen. You're going to like go get lunch, make coffee, do some other stuff. But what happens is when that job's done, meter's still running, tick, 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 tick. So, that can, you want to be very efficient and have a batch process. So as soon as one job's done, fine, I don't want to clap because I'll just like, boom, you move on to the next one, and it does the next job, and then the next job, and the next job, and the next job. There's no idle time. We are merciless with these GPUs. They are so valuable. You just keep them churning, keep those suckers hot. The other part is sharding. So I was fortunate. I asked Google for, I got greedy. I said I needed 8 GPUs, because if you did the math on how much compute I needed, it was going to take like months to do this. But instead, if I could run, say, 8 or so of these GPUs in parallel, then it can be done in about 5 or 6 weeks, because I distribute that load. And so I wrote some software that did some sharding. It took my pool and it split it up across 6 to 8 different GPUs and let them run in parallel. So those were some efficiency plays that I can recommend to help streamline that process. But what I was trying to do is something that's really, really big, and it's probably bigger than I should have for a project like this. What I wanted to do, I called it Deep Shape 3D because I thought it sounded cool. And yeah, Robert. Oh, did you give me the, like, I'm running out of time? You're scratching your head? Okay. Okay, let me know. All right, it's all good. And so the project is just like any other creative generative model, like Midjourney, generate this picture, or VO, generate a video. What I want to do is go from text to a 3D printable shape, one that I could use my home MakerBot 3D printer to actually, I want to say, like, create a sailboat, and like create the sailboat for me, because I hate the modeling part. That is a drag. That takes forever to actually do all the CAD modeling piece. I just want the object. I also wanted this to be something that could be run on the cloud. So, if I thought others might want to use it, or maybe there's a way to monetize it, what you could do is you can have it hosted on a cloud platform, and then put like some sort of SaaS front end in front of it, and folks could like, oh yeah, I'll pay 10 cents to create a 3D printable shape that looks like this. So it had to be cloud native and scalable. And I thought it would be helpful for different domains, like, education, additive manufacturing, and industrial design, things like that. So I kind of had this plan. This was the shell of the plan. And in it, there were some more specifics. And then that's basically what I sent to the Google Cloud folks. And they thought it was cool. And like, yeah, all right, authorized for a lot of hardware quota, 20K in credits, just go to town. So now that I got my, my project, I needed the actual plan. So the plan was here. This is what I'm going to do. I'm generating 5,000 text prompts. Generate a sailboat, generate a coffee cup, generate a chair, generate a clock. I'm going to look at things in the room, right? Generate a screen, generate a projector, whatever. 5,000 of those. And that's a lot of work. And there's no way I'm going to type 5,000 prompts. So I asked, GPT, create 5,000 prompts, right? And so it spit out all those prompts. I think because of the context size, I did it in chunks of 1,000. Like, give me 1,000 prompts that are organic, 1,000 prompts that are architectural, 1,000 prompts that are industrial and home and toys and all sorts of things. And it generated a nice list of 5,000 create a blank prompts. The other thing I needed is a smarter model than what I was going to make. And I found there's a bunch of models, what's going to actually generate the output. I found a model out of China that that generates 3D shapes for games. So for the game developers out there, it just creates simple meshes. They have their outside normals. They're hollow. There's nothing to it. It's just a facade of vertices and panels. And so what I wanted to do is have that generate the raw mesh shapes and then apply a post-processing effect to then make it that's 3D printable. So that's things like creating manifolds. So there's a front and a back, making it solid, making it so there's no overhangs or holes or things like that. And then from that, I had my specialized training data set because now I've got 5,000 prompts and I've got all these 3D printable shapes. Go train the model and then get let the millions roll in. So first step, creating the prompt. And this is kind of an example of what that prompt output looked like. GPT, the instructions were very clear. I wanted a CSV file that had a unique identifier so I can do some tracking and then some sharding. I can say, this GPU is going to have 1 through 500, 1 through 1,000, 2,000 to 3,000. So I can dish them out by ID. I needed the prompt. And then I added things like categories just to kind of help, categorize things. I thought this might be something I want to play with later. Didn't end up using it, but still interesting nonetheless. And I took these prompts and I ran it into that smarter model that's meant just for creating game assets, just 3D game art. And it would generate a bunch of models. It generated 5,000 models that basically matched, it's a coffee mug. It's a simple boat with a streamlined front and a flat rear. Okay, I can't even read anymore. And these are examples. This is like an example it generated for boats. It actually, it loves boats. It had like 50 boats for some reason. But these are the two that I thought were worth mentioning. Because after you've generated all your raw training data from the model, the base model, the teacher model, the next thing to do is go through and either fix or check it. So in 3D printing, these holes, I don't know if the cursor's showing up, but holes like this are a major headache. They screw up your 3D prints. But they, for some reason, don't do it till it's the very end of the print. So you've already invested hours and then it screws up and it's super depressing. But this is a nuisance, but like this whole structure, I don't know what it was thinking. Like a tugboat thing. Oh, what, really? 5 minutes left? Okay, I'm gonna have to like speed it up here. And so I use tools like Mesh Labs and TriMesh and things like that, post-process to say, oh no, if it were just a hole, fix it, fill it. If it's this whole structure, kill it, take it out and get rid of it. And so what I ended up with is I want to see where I'm at. What I ended up with is all my prompts that are good and all of the meshes that are good as well. They're 3D printable. And then I created, basically you need a manifest to hand off to the training model. So it's like, here's the prompt and here's a path to that actual, if I were smart, that would have actually said boat. So it would all come together. But basically you would have to give it the training instructions as well. And then just some stats around what it learns. It learns how to match those descriptions to the actual mesh shapes that were generated. It learns how to do the manifolding to make sure it's actually printable. And it just learns that it can fit within the printing sizes and constraints of 3D printers. So this is kind of a summary of what it took. So I actually took GPT. It generated those 5,000 initial prompts. That only took 2 hours. I had a Google Cloud Notebook hitting out this endpoint, the completion API, over and over and over for 5,000 rounds and got those 5,000 prompts. From there, I took this other 3D generation model. I ran that on 6 GPU servers, and that ran for 2 days straight. And that generated the raw 5,000 baseline shapes with mistakes. It took another whole day to go and evaluate through software API calls using those tools I mentioned, Mesh Labs and TriMesh and Blender to some extent, and validated and fixed most of it to the point where I got about almost 80% success. I got about 3,800 or so usable shapes. And then from there, I'm like, okay, here's my training data set. I've got the prompts. I've got the manifest that says what those prompts contain. And then I've got the actual mesh shapes that you're going to learn. And I fed that all to the GPUs, and it ran straight for 5 weeks. And as it went from those 5 weeks, there are checkpoints. So, it's not roll the dice 5 weeks later. Oh, damn, I forgot to do something. Instead, you have checkpoints along the way, and you can find out really quickly within like the first few hours if things are looking right. And then you keep checking those checkpoints like every couple of days. Are we on target? Is it getting better? Is it getting worse? How things are looking? I don't know, maybe run evals, right, on those checkpoints. All right, Darius, evals. And then you've got your whole data set done, and you've got your model done. You can deploy the model, and then you can run hosting and inference on that model, and anyone can use it to generate it. And then as you continue this process and get better and better and better, you're able to refine the model with different versions, different data sets. This is the last slide. So the lessons learned here is anyone can build a model. I know I ran through things really fast, but this was a little bit of a tricky problem with a lot of post-processing. You can start small with smaller examples. Just think about the problems you're solving today. I spoke during one of the breaks with a gentleman who works on firewalls. I'm like, oh, cool. So you've got a lot of firewall traffic data, right? And you can see what a normal pattern looks like over the course of 2 or 3 months of traffic. And then that way, when a new patch comes out, you can see if the traffic is abnormal or skews. So you can train a model to just detect irregular traffic. So that's firewall. I'm working with another company in finance and another company that's looking at how to do this information for healthcare. So think about your own problems. I mean, professional, like startup problems, the problems you're trying to solve, and how a fine-tuned custom model can be built that's just to solve that specific problem. You can do it on a budget. You can hit up these big cloud providers for credits, and making sure you have clean, quality data is the absolute key. And planning. Once you get those credits, treat those GPU quota like gold. It's precious. And I think that's it. So anyone wants to connect with me on LinkedIn, I respond to everybody. So even if it takes a few days, because it gets busy. No, I do not. I don't like AI assistants for some reason. They just, I think that's why it takes days. You know, if you send me something and you got to respond in like 10 minutes, like, oh, okay, AI assistant. But no, I definitely reply to everybody. So, okay, questions, or am I way out of time? No? Oh, sure, I saw you first. Okay. Yeah, you in the back. Yeah. For this, this was the Hanyuan 3D model by Tencent. So it is a Chinese model, open source Chinese model too. I often start with the Hugging Face. I look at the model cards. I do a lot of search there. I try to find things that I do. It depends on the purpose. If it's a research project that I'm doing, I start with Hugging Face. If this is an actual deployment, like I want this to go to market and to be a product and I want for a startup, I like to look at together.ai and look at their serverless AI models. They've got a great collection of serverless AI models that you can do fine tuning with a LoRa fine tuning layer on top of it. And then you're not paying extra inference and hosting fees on it. It's a really good solution to just get your feet wet. Okay, yes.
Your project.
Oh,
So
thank you.
for Deep Shape 3D, did you consider products like Google's Gemma? And then if so, like, or if not, like, what were the pros and cons in your thought process?
So I guess back to which model I selected and why I chose the Hunyuan 3D model over Gemini. It really depends on the problem I was trying to solve. It really also depended on the cloud platform support for it. Gemma, I was at a point where so I did some testing. So I guess that's the easy answer is I first pick a handful of models. I do one case and just see which one works the best, fastest. When I found this other model that it's really hard to pronounce, I just latched onto it and just went with it. But definitely experimentation is the fundamental key of AI research. And experiment with prompts, different models, different techniques. Oh, cool, sure. All right, yeah. So I kept them at low fidelity. So like even when we look at that boat, it was like, come on, really? That's kind of a lame boat. It was just my starter exercise. I wanted to prove a concept. I wanted to prove that I could actually train a model that would be really good at 3D printing and but not, you could take this further where you can now talk about scaffolding and using different materials in your 3D prints. And then CNCs, right? So there's a lot of different fabrication processes that you can take from here. So this was really just a research project and experimentation. And so that kind of is what led to that. Did I answer your question or like dance around it? Okay. Okay. Yes.
Question about
Yeah. Yes. So, in terms of privacy, you do want to know a little bit more about the model history. Like, you want to validate that you're getting good results. So that's for me what I do as I start with a benchmarking exercise to see what I'm getting out of the model just untouched and untampered with. I will say though, when I used in a finance project I did, when I generated those samples, those 5,000 samples, they were financial questions, specifically financial scenarios. And unfortunately, there was a lot of bias in it. It would be like Roberts, has $1 million and like Susie has like $5. And unfortunately, it was doing a lot of skewing in the training data. So I had to actually go through an exercise to make sure it's just the client or the customer or the company. And you want to debias your training data as much as possible. I should have led with that. But yes, so debiasing, making sure there's no proprietary or secret information in there is absolutely key. But I haven't gone through really rigorous exercises to go deep on that. So yes. Right. So, I talk about this as
You repeat the question.
oh, right. Great point. Darius was great at that. I'm bad at it. Thank you. Well, shoot, now I forgot what the question was. Oh, right. I said early on that training your own model is your core IP. I firmly believe that training your own model is the core IP. And I equate that to actually training your own employee. Because you are training a
And it's possible to get this property because it's kind of tricky what you can get the property, like intellectual property, and which is open and you cannot get it.
Right. So building that intellectual property, it's pretty commoditized. It's very easy to do. But I do think, what's super important is that you're training a model that's exclusively yours. It's going to solve a problem that you are trying to solve. And in this case, I was trying to solve the problem of 3D printing. No one else has that. And by the way, when if this would theoretically go to market, this would be based on an AI model that cost $20,000 to make. Thank you, Google. But so that is actual IP that nobody could replicate. You know, they can't open up Cursor and have generative coding create something so easily. And oh, that was your question. Yes. Okay. Other questions, or was that unsatisfactory?
Last question. Who wants it?
Well, last question here. You can always hit me up on LinkedIn and I'll answer your question. Okay. Yes. Take us home.
Do you have this model in somewhere on Hugging Face?
No, this is all on Google Cloud Platform, and it's going into the GCP Model Garden, and so it'll be available there. I mean, putting on Hugging Face is the next step. I just haven't gotten to it yet.
Thanks.
This is all, you know, only a couple months old. So, yes. Okay. Am I?
There one last person who said, "Oh my God, I want to ask that final last question."
Nobody.
God, we got a
Nobody's
couple.
that. Okay. Oh, well, look what you did. Now we got 4. No, it's just mean. Come on, Rob. All right.
Good to let you go all 4. That's it. Go.
All right. Yes. I'll start here and I'm going to like swing to my right.
I have a very basic question. Why?
Oh, right. No, I looked at all of them. I looked at AWS for startups. I looked at Azure. I looked at GCP. Okay. For me, there are 2 different categories of cloud infrastructure. You've got like traditional cloud infrastructure, like these guys, like GCP, Amazon, and Azure. And then you got like the new guys, these like startup infras they're called, like super based together. You know, sort of like they've only been like 5 or 6 year old companies that are like throwing up GP resources. They've got the slick UI. They've got like the cool, you know, very responsive UI. Whereas the old cloud guys, very complicated, very hard to use. GCP was like right at that intersection. They got the easy to use UI. It's very quick and easy, developer friendly tools and frameworks for building apps. And so I vibed with them. What can I say?
If you were to do it today, what would you advise?
I would follow that QR code and get my free money and tell them I'm going to build like an awesome AI model they've never seen before, and ask for as much as I would ask for. If I were to do it, I'd ask for 100,000. So they only $1 million. Yes, exactly. Okay. Yes.
So monetization.
Yes.
How are you going to monetize this? What's the game plan for that?
All right. Well, I hadn't really thought about that, but if I were, you know, you'd probably put a SaaS front end, or maybe go the Midjourney route and just you collect payments through a front end, and then you let it pass through on Discord or some other channel. But it would be something like, yeah, okay. For honestly, what I'm seeing a lot in AI, because it's token based on inference, it would probably be something that's credits, right? You spend $10, you get 20 credits. And it's 1 credit to generate a model, and that way you take the mental aspect out of spending dollars, and you're just spending credits. Like credit. I don't care; they're just credits. But you know, you kind of forget it's actual money. So buying credits, using credits to actually run inference.
So how is Google making the justification of giving you all this money for based upon your game plan?
So because they're kind of like in a missing match with like AWS, and like we got the cool developers, and look what our developers are building, and at Google I/O they could show things like this, and so they always try to one up each other. But I think that's kind of a snarky answer. But I think the real answer is that, you know, all these companies really want to foster innovation, and it's like, has anyone ever noticed how like the most awesome iPhone apps become part of the next iOS release? It's so coincidence? I don't know. But like, I'm sure that there's some of that, you know, they want to find this sort of approach and then find a way to work it into their garden so that they have it as part of their portfolio. My guess. I probably shouldn't be speaking on behalf. I'm so getting sued. Okay. All right. You had a question, right? Oh, Rob, I'm sorry.
Let's go. Last one.
All right, fine. This is the last one. This is the real last one.
I can cross this line.
All right.
Just a basic question. But curation, is this part of the model itself? Like, how do you? I mean, you can't possibly go through all the 5,000.
No, what you do is you write code, and there are tools. Like I said, Mesh Labs. It will actually have a slicer, and it'll go through all the generated meshes and tell you like thumbs up, thumbs down, what are the problems. And Mesh Labs is even so good as it will actually patch those holes for you. So you do use another tool to help with the validation. That's an important step that I probably should have definitely emphasized, is there's additional validation tools that you can work in here.
So Wouldn't that be biased? Like, how do you know?
Yeah, and right. We're biasing to what's printable. We're biasing to what will succeed in a 3D print, and we're casting out these guys, the top model, that won't 3D print. That's like what we wanted to train into this. And as you develop your own models, and we can talk about approaches, you'll want to figure out what it is you want to train the model to do and bias it to do or bias it against. And then another time we'll talk about reinforcement learning, which is even more fun. Okay, yes. All right.
Yes, I like, all right, there you go. Okay, sir, clear. You know, I think I know the way I look at a good presentation is when there are lots of questions, right? So we've had 2 great presenters, so I'm really psyched about that. And you know, there'll be no questions when I speak. So that'll tell you what that means, right? So I'm going to try to get everyone out here on the time that we promised. So I might skip a slide or 2. Let's see where we're at here. All right. Just a little, I'm going to skip this for now. So Silicon Valley AI think tank, creating a roadmap for AI success. So one of the things that I say is, you know, everyone's focused on the technology. But ironically, companies are not successful because of the technology, is my argument. Companies are successful because, guess what? Take a guess.
Solve
That's it.
You
Yes.
problem.
People, you, culture. It's all about the culture with technology. Right. And if you're, you know, there's, you know, when we think about AI, if you're reading all the rags, you know, you're hearing AI is going to replace you. You're going to lose your jobs. It's doom and gloom. And a lot of what I'll be quickly speaking about is how history repeats itself. So I remember when the PC came out. How many people remember when the PC came out? Right. So when the PC came out, guess what? We were going to go to 3-day work week. There's going to be less work, right? Same thing with AI, right? In that, what really happened was that more work, you know, people were working harder. So what happened with the .com? Does everyone remember when .com was going down in 2000? There were going to be no more brick and mortar stores in 2 years. Every brick and mortar store is going to be closed. Well, you know, it's 25 years later and there has been a significant shift. Absolutely. But it took 25 years. Mobile phones, right? You know, they've changed our world. Also takes time. So somewhere between AI will replace you and AI is at worst a tool that could help support you to sort of do your job better. So when companies, why is AI so difficult to sort of implement? It's because it's a radical transformation of culture. It's a radical transformation of education. It's a radical transformation of how business organizations are set up. Right? Business organizations were set up in verticals because the humans could not grok so much information across an entire enterprise, right? It was just too much information. So you had sales and marketing, you had engineering, you had, you know, manufacturing. Well, now sort of with the advent of AI, you can kind of bring all that together in one small team of 5 people, and they can go across the whole company and they can grok all that information. So that means the whole structure of organizations have to change. And those organizations that are able to adapt, particularly the enterprise, it's easy for a startup to quickly adapt. They're 5 people, they can do that. But when you work at a bigger type of company, to restructure your company as you're sort of driving the car down the highway is a very difficult thing to do. So a little bit about me, 25 years, Silicon Valley, founder, think tank, quick bites, did a lot of work as a program manager. I am currently in TPM, AI TPM at Intuit. the best enterprise type of company doing incredible things in AI, and approaching it right. But even trying to approach it right, it's such a difficult thing. I will talk a little bit about that. Really started getting involved by managing data science teams at BNY Mellon. And like I was talking 2017, I founded this all started with Silicon Valley Project AI. All right. So I think John told me I should not show this picture, but I was speaking, since I'm from Monterey, I was doing a talk for the Navy postgraduate school, right? And they said, we were talking about AI and they challenged me, do you know how long it takes to sort of put together the plan and build an aircraft carrier? How many years? Boom, 10, right? So I said, you know what? I'm going to go off. I'm going to use this tool called Cove, and I'm going to put together a project plan to build, a Navy, Air Force aircraft carrier. In like 5 minutes, and I talked to someone afterwards, it usually takes a year a year or two, I think, to put together the project plan. This was my epiphany. I was like, there are certain things that AI is really good at, and sort of putting together a massive project plan to build an aircraft carrier is kind of one of them. And this is like free. Like, what I was also surprised is like, this information is like freely available. Like, you could just ask. So that was a big change for me, the power of AI. So when we talk about transforming an org is hard, implementing AI in the org is harder. Doing both, and I have a good buddy. We've been involved in Agile like for a long time. So those people who've been involved with Agile, right? Agile was going to change the world. It was going to change the way we work. My opinion was that where it failed was it was very technology focused. It didn't have the buy-in of the complete cultural zygotes of the enterprise. So when you're talking about AI now, you're not only talking technology, which is really hard, you're talking what Agile's been trying to do for 25, some odd years, right? You're trying to do both. That is ridiculously hard, right? So if you want to be successful, it's not just the technology. That's a very important part. But the other part, and this is why, near and dear to my heart, is sort of the cultural part, is the people. You're not going to replace your people. You should retrain your people. You should be educating your people, right? So that they understand like what AI is. How does AI work, right? How can they incorporate it into their job? How can they use these tools? You'll be surprised. I work with a lot of very technical people. And what I would say is a lot of them don't know how to prompt. So I would say, if you're going to take one thing away from what I say in this speech, the one takeaway is learn to prompt, learn to become a very good prompter. And we could talk more about that later. But and I showed this, I think, in our or maybe 2 meetups ago. So Alvin Toffler, in 1990, the thing that blew me away about this quote was, he said this in 1990. Right. So he was so forward thinking that he was able to say basically the impact of AI. So what's going to be the impact of AI? It's no longer what you know, right? It's your ability to ask really good, right? Your ability to prompt, your ability to learn, unlearn, and relearn. And what he meant by that, or my interpretation of what he meant is, and what I'm going through right now, and I think a lot of you are probably going through right now, is the learning so incredibly fast. Things are changing. I follow this closely, and every week there's something new. I can't keep up. There's a stress of trying to keep up with the speed of learning, right? So And then you have to unlearn what you learned because it's no longer sort of as pertinent. And then you have to relearn. So the ability to be able to do this is at the key. But then he talks about sort of the stress that puts on not only humans, but in entire countries and the world of this incredibly fast pace of learning. So one of the things, even if we're all, these doomsayers are saying AI will take over the world, here's why that's not going to happen. What he says, and what I agree with, right? I always like to say I'm not that smart, but I know some smart people, and I'll quote him, and he said this, and I believe it too, is that whether consciously or unconsciously, we will not let AI sort of progress that fast. AI is moving way faster than we could grok, and we will, again, unconsciously or consciously slow it down. How? Government regulations is just a simple way, right, to slow sort of AI down. Fear is a way to slow AI down. So there are a lot of different things kind of going here. So that's where you're not going to be replaced by AI, but where you might be replaced, which I think is valid, by someone who's learning AI and learning how to prompt and learning how to use the tool and learning how to sort of ask the right questions and partner. AI is not only your friend, AI is your partner at work. Working with you is part of your team. Those organizations that truly adopt AI as a partner, as a teammate, are really going to thrive. So the good news is what is old is new again, right? And you can learn these transferable skills. So there's the opportunity. Everything is so new, you can be an expert in 6 months that most people don't know, or are only learning. So there's an opportunity in all this change, right? Like change is a great opportunity. Let's see what we got here. So AI first needs to be built into your DNA, right? So the companies really have to, when you say you're going AI first, Intuit's going AI first. What they're doing is they're constantly retraining people, educating the employees how to use AI, from as simple as how to be a good prompter to challenging people to use AI every day, which sounds crazy, but one of the things that I would say, and I think John or Darius was saying it, I think John was saying it more, is, just do it, right? So what do I mean by that? You got to start somewhere. You just start using AI, right? Step by step, you're learning, right? At first, you don't know that much, right? You're writing your first prompt. Then you're putting together your first, application. Then you're doing your first agent. And it takes time, but you have to start. That's the key. Don't be afraid. Old school. So I think when I read this, and Paul Graham obviously is a big Silicon Valley hero in some ways to some people, but let that soak in. So what is he really saying? It's sort of like when Darius said you could write now an application in 2 days. You could write it out. It takes about 2 days to really get it working. It's all about solving user problems. So when we're saying old school, what's old is new again, anyone can build an application these days, fairly easily. But understanding what the user problem is and solving that problem, that's the key, right? And that's always been the key. Nothing's changed. That's old school, right? What's old is new again, right? Don't ever forget that when you're using AI, you can do an incredible, you can write a 50-page paper in like 5 minutes. Is anyone ever going to read it? No. right? It's like, who reads a 50-page paper these days? I'll put it through ChatGPT and I'll summarize it, right? So you want to add value, right? So you're solving user problems. And that at its nut is the serious, So what do you think, what's missing? This is like, I think if I remember when I got this is like Microsoft's sort of data science life cycle. I've said it a couple of times. Anyone want to take a guess? People. There's no people in there. There's no culture, right? It's all about the people, right? So this, to me, is the sort of agile view of the world. It's all about technology. It's not about people. It's not about processes. It's about technology in a way, right? So new school, old school. So now, like, this is the loop. Like, when you're working in an enterprise these days, again, you can create an app in 2 days. But the things that the hoop you will have to jump through, right? You're going to have to deal with security. And these are going to be hardcore security people who are going to want to know, can they break your AI or whatever you built? Is it susceptible to sort of someone hacking into it? Governance, right? Governing AI and ethics, right? And, protecting the PII and personal, identifiable information, PII, right? There's going to be a whole group that's really interested in ensuring, right? And, if you're building your reputation as a company, you are going to build it on trust, right? You're not taking people's data and looking at it or sharing it or selling it to third parties. That's all you're governing, making sure that you have integrity, right? And if there's something that Intuit does, they do a lot of things really well, but the governance of ensuring that, from responsible AI, they take that extremely serious. And then when I talk about culture and collaboration, the fear, you have to deal with, people are going to be fearful. Whenever I talk about change, right? Even if it's good, in the 30 years that I've been working, right? Change is very hard for people, even if it's really good. And AI is a kind of change. So like once in our life, it's similar to .com, but I would say it's .com on steroids, right? So you have to address that. Lack of company guidelines. Your CEO should be communicating on the importance. Your leadership should be encouraging you to use AI. When I share with people all the time, here's how I'm using AI. I'm using it and I'm proud of it. Like stating, I've used AI to write this position paper. I used AI to write this Slack. I've used AI to write this email. It's all good, right? Everyone does it, right? If you're working in a corporation that's, no one's sharing that they're using AI, that's a red flag, right? It's a red flag because they're not really having the culture. Procurement challenges, of the different types of software that you can get, and dealing with PR and compliance and new processes that these tools kind of bring in. Understanding the capabilities, there's the software development life cycle, right? And data science is significantly different, right? And how that works. So you have to have a whole different management style of working with your teams. And then the legal barriers. How many people have sat on phone calls with your legal team? How enjoyable is that? Right? And they're really great. I thank you for watching this. But they look at sort of the work you're doing from a completely different perspective, right? How are they going to be, legally at risk? So you have to be thinking of all these things. Anyone can put together, oh wow, time's going fast. There's no one to pull me off. So No, so I have to manage myself. So I'll go a little bit quicker. But, you know, you can do a prototype in a week or two, but to sort of build and deploy a scalable AI product in an enterprise is sort of, you have to think about all these different things, right? And that adds a lot of time, effort to sort of get it right. So let's see what we got. So very quickly, just like an AI maturity model, I kind of took this. You have it's really all built on culture. I talked about reputation, right? That you want to secure. Your reputation is all you have, right? So then there's training of your people on what the tool does, how it works, how it can support other people, government regulations. And now you're going sort of up the maturity till you get to transformational, when you can do all this and it's truly part of your DNA. So just very quickly, if you're looking at a project plan of the 6 steps to design and build and scale AI, you're scoping. I can't tell you how many teams I've worked with that truly don't understand the problem they're trying to solve. They just want to use the technology, jumping right in. But do you really understand what the problem is? Does the problem even need AI, right? Sometimes you can just use an Excel spreadsheet. You know, someone's really good with Excel or Google Sheets. You don't actually need AI. So it's kind of understanding what you're solving, determining, what the ROI is. And it's another thing, the lack of conversations around, can you actually make money on this? Is sort of unfathomable, in my opinion. Skills that you're going to need. How many people have had issues with data? I've seen projects go for months, and then when they actually try to get the data, they can't. They can't get it because there's a fiefdom, perhaps. They can't get it because it's not actually being generated, and they're going to have to go up the stack and make a change to the front end so that they can actually collect the data. So you've now just lost 6 months because you're going to have to roll out that update, and then you're going to have to build enough data so that you can actually use it. I've seen this all. It's testing. We had a great talk on that today. Optimizing, tuning, cost reduction. And then when you're in production, you're going to have to maintain it. You're going to have to monitor it. All these things go into it successful. There's no accident, right? You don't get lucky with AI, right? This is a lot of hard work. And this is why 90% of the people, 90% of companies fail, right? Because it's a lot of hard work. Okay, so very high level. Even more important is if you don't have a vision and a strategy of where your company is going and what they're doing and why they're doing it and how and what to build with AI, you're going to be off the mark. So these people are going to start building stuff. I've seen this happen. They're building stuff that don't really ladder up to what your company needs, right? So this is a company that has to work top down and bottom up. And I'm just going fast here. So if we go back to our agile view of the world, right? I'm a big believer in think big, work small, right? You kind of have to have a strategy and mission of what you're doing. If you don't have a strategy and mission for your company and people don't really grok that, Intuit again does that very well and communicates that, then what you start working on misses the mark. Right? And with AI, it's a lot of mining for gold, right? You're doing a lot of discovery work. If you get down into the lower, into the trenches, what I like to say is that sometimes they let teams dig for that gold for months and months. There's no gold there. At some point, you got to kill shit. You got to kill it and say, there's nothing there. Let's move on to something else. And if you don't have really laser focus on what's important, You could waste a lot of time and resources digging for gold, and there's no gold. So, all right. So I like this. We're almost at the end, I promise. But when you look at the complexity of sort of, there's Gen AI, that's, fairly recent. When I started in 2018, it was all about sort of supervised learning, unsupervised learning, reinforcement learning. And why I love this is that it kind of breaks down, here are the learning methods, here's the algorithm, here are the applications, and here are the use cases. So you can connect the dots, right, of what's right, what we like to talk, what's the right use case, right, that you're trying to solve. If you don't understand what you're trying to solve, you may end up picking the wrong sort of method to solve it. So it really becomes a very good product person, a really good AI product leader has to understand this, right? And start working with your engineering team. So what did we learn? Implementing AI is hard, right? Good news, you're not going to be replaced by AI. There are going to be a lot more jobs that are created. There will be people will lose their jobs. I'm not saying that people won't lose their jobs, but there's an opportunity that there'll be more jobs created. Just like with the PC, just like with .com, just like with farming in 1920s when they brought in mechanized machinery, right, in the 20s, and everyone from the farms lost their job. What did they do? They invented the U.S. educational system, and they went to school, and they learned, went to high school, and then started going to college. So, there's going to be a lot of change. It's up to you to jump in and start learning now, right? And educating yourself, right? Because no one else will do it for you, but that's the opportunity of learning, unlearning, relearning. That's the 21st century. Build AI into your, company DNA. Old school, new school. Certain things don't change. You got to build a product that people love, right? AI is not going to help you. Well, not true. AI could really help you a lot, but, that's the softer skills of, really understanding your customer. AI maturity model. I didn't show you the house of AI. I'll include it in slides. Top down, bottom up, think big, work small. AI is really complex, right? All right. I thought about this a lot. I don't know if you're going to be willing to play along, right? So the 10 reasons why AI projects fail. So if we want to all say them out loud together, like we were playing, or what's that game show? No, not Jeopardy. Family Feud. Are we ready? Applying application development approaches to data-centric AI. That's a classic failure. Lack of sufficient quantity of data. Lack of sufficient quality of data. You don't have good data. ROI mismanagement. So actually it costs you more to solve the problem with AI than you're actually saving. Lack of planning for continued AI model iteration and life cycle. So after it's in production, there's things called drift of your model. So you have to constantly maintain it. Misalignment of real world data, right, with the actual data that was training. So you trained it on training data, but the production data is different than what you trained it on. So you learn. Misalignment of applying proof of concept thinking to real world pilots. So speaks for itself. Underestimating time and cost of data component of AI projects. That one happens that's been happening for 7 years, of how challenging the data is to get. Vendor misalignment, so they're going to promise you the world versus reality, and over-promising and under-delivering, right? So very easy to deliver something, a proof of concept, but to scale it up and make it effective, right, is very difficult. So great technology alone doesn't solve your problems. Neither does simply throwing more people The solution is really a robust, iterative, scalable method by which to reliably run AI projects with a high degree of success. So hopefully this has helped you along the way to understand there are a lot of steps to do that. And are we going to get a question? Are we going to get one question? We got a question back there. All right. So I'll feel good tonight. So thank you.
We use AI to do this presentation.
I didn't. I did use a professional designer to do it, who I've worked with in the past, who I really like. This is how I work and how I write is I grab information from a lot of different places and then I kind of distill it down. But it just so happens I didn't. I did create the questions we handed out with AI.
Wow. The first point.
So the question is, what is, using a software development life cycle, which is more deterministic, right? When you're coding, that's, A plus B is going to equal C. When you're working in data science, it's really about allowing your people to do discovery work, right? It's not A plus B equals C. It's A plus B sometimes equals C, sometimes it equals D. And I'm working with this right now. How do you work with world-class PhDs, data scientists in a structured manner, but yet give them the flexibility to really think through very challenging problems? Completely different sort of styles of management. I know people are leaving, and if I don't know. So any other questions? Oh, yeah, please.
Where would you start in an enterprise that is so used old way of doing like data science, IT, cloud, like there are like all these technical partners that are doing their part, and there are these functional partners, either pulling a vendor, do the job for them, or are submitting their request to IT to get something like AI tool for them. But where would you start is the journey of getting to AI driven?
It's a great question. What I would say is that the level of urgency is so high right now. If this is not driven by your senior leadership team top down, you're in trouble, right? If you try to get a bottom up revolution, not that it can happen, but this needs to be top down, saying the whole company is bought in to sort of becoming AI first. That's what's happening at Intuit right now. This is coming down from the CEO. The goals of the company are all built around AI. That's the only, you have to move so fast at the transformation is happening. So in whether 2 to 5 years, 2 to 3 years, and just putting in the infrastructure to do this right takes years. The technical infrastructure takes years. So if you're not all in right now, you will be years behind. It has to be top down. My opinion.
So I've tried to ask AI this question, ChatGPT this question, but it keeps timing out. Has AI really created its own language to talk to AI?
I've only read something like that. I can't really answer that. I heard computers speaking to computers in their own language. I don't, what's true, what's not true. I'm not really sure. I'm not really qualified to answer that. I did read an article on it. All right. So here's all the information. You can take pictures. Thank you all for coming. Let's set up another sort of meetup. Really looking forward to that. Follow me in my newsletter. I release it every week. Really kind of speaking to AI and strategic leaderships and what's going on in AI to help, your cliff notes to help keep you up to speed. Thank you so much for coming. Thank you for your patience at the front door. There may still be beverages that you can get or grab a beverage on the way out. And please eat more pizza, because I think last time I brought home like 6 boxes of pizza and I had to eat it all myself. So help me out. But thank you very much. Have a safe drive home. Really appreciate your support. Oh man, always good to see you. Thank you. I wanted to use
Like that.
Yeah, right. Nice to meet you. Pleasure to meet you. Yes. Yeah, no, I'd love to do that.